are these two problems. So problem 1, I want 3i times, and then problem 2, I want 5 minus 3i, okay, times 4 plus 3i. All right. So multiply these out. And see, when I multiply across, that's going to give me 6i minus 3i squared. And the big difference between, I told you to treat the I just like an x. The one step you have to do is if you see an I squared, that's the exact same thing as -1. So this is really 6i minus 3 times -1. That -1 makes that a plus, so we end up with 6i plus 3. And we're done, sort of. When you're dealing with complex numbers, I didn't make a big deal about this before because I was worried about time, but the standard form of a complex number, and if you look at a book or any place online, they say the standard form of a complex number is a plus bi, meaning they want the real part plus the imaginary part. So when you multiply this out, to write it in standard form, you would write this as 3 plus 6i. Would I mark this wrong? Of course not. It's still correct. I'm just telling you, this is when you write a number, the standard form of a complex number is the real part plus the imaginary part. All right, next up, do the same thing, right? We're going to multiply, treat the I just like an x. So this is going to give me 20. I get minus 12 plus 15. So it's going to give me plus 3i, and I get minus 9i squared. Simple binomial, multiply it out. The difference is when you have an I squared, that is now a -1. And since that's a -1, right, because I squared is -1, that means we're going to have 20 plus 3i. That's going to make that a plus 9. And so my final answer is 29 plus 3i. Okay. So there's our little review of, multiplying by I. Why did I want to do a little review of multiplying by I? Well, we need to go back and divide by, like how do you divide complex numbers? And the reason we need to divide complex numbers, I ran out of time when I taught it the first time. Like I rushed right at the end, and I want to make sure everybody knows how to do it. So, what does division look like? Well, division is a fraction. So if I have, now let's say I give you 6 over 5i. So we're gonna work our way up. We're gonna start off with basic division of I with complex numbers to a little more complicated. So this is what I call basic, right? The reason I call basic is you basically have a single term on the top and this single term on top and a single term on the bottom, and your job is you can't have an I in the bottom. That's your job, right? So you got to get rid of the I in the bottom. And how do you do that? Well, the one fact you know is that I squared gives you -1. So if somehow I could get an I squared in the bottom, then it would go away. And the only thing you're allowed to do is multiply top and bottom by the same thing. So we're going to multiply. Kind of the trick here is you're going to multiply top and bottom by I. And so that gives me 6i, and then this gives me 5i squared, which is going to give me a -5. And my brandy marker doesn't write particularly well. Okay. And so what's my answer? My answer is 6i over -5. And this is a perfectly acceptable answer. I like that's fine. Some textbooks would actually write that as -6 over 5i. I honestly don't care. I just want to make sure you understand these are the same thing. Okay? But notice there is no I in the bottom. And this is still of the form a plus bi, where it's technically 0 minus 6 over 5i. The real part happens to be 0. The imaginary part happens to be the -6 over 5i. All right, so there's one division problem, and I'm going to call that the easy division problem. A harder division problem looks like this. What if I give you 3i over 2 plus 3i? Okay. So this is a harder division problem. Now, how do we deal with the harder division problem? Well, okay, kind of the explanation that I gave like last week on this. We walked through some steps, but kind of the end result was the way we get rid of the I in the bottom is we have to multiply by the conjugate. And we use those technical terms. But basically we want to create a difference of squares on the bottom. So our difference of squares on the bottom is 2 minus 3i, 2 minus 3i. Okay. So the key here is that when we multiply the bottom out, this guarantees that we don't get an I in the bottom, and I kind of do some scratch work right below it. My scratch work below it is this times this gives me a 4, this gives me a minus 9i squared. And I squared is a negative 1, so this is going to give me 4 minus, and it'll be 4 plus 9, and so the bottom gives me 13. That's kind of the big deal. You multiply the conjugate, so you get rid of the I in the bottom. And then the top, you multiply. And when you multiply the top out, you're going to get that 6i minus 9i squared. Okay. But that 9i squared, we know I squared is negative 1. And so that ends up being a plus 9. And in general, the way we're going to write this is I want to put the real part and the imaginary part, so that gives us 9 plus 6i all over 13. Now the way they write this in, so to put this in our standard form, which is a plus bi, is, I'm going to kind of refer back to something I did yesterday. Anytime you have a fraction with a single term on the bottom, you can break this apart. And if I break this apart, that's going to give me 9 over 13 plus 6 over 13i, where I have a real part and I have an imaginary part. And I don't know if you noticed, but the multiplication did on top was the same as the multiplication I made you do before, because I wanted to make sure we knew how to do all of that. So, your turn. What if I gave you 5 minus 3i over 4 minus 3i? Pause for a second. Okay. So, your job is to get rid of the I in the bottom. And if you have 4 plus 3i, guess what you do? What are you going to multiply by to get rid of the I in the bottom? Or 4 minus 3i. So what do we have to multiply to get rid of the I in the bottom? 4 plus 3i. So we're going to multiply by 4 plus 3i in the top and bottom. Pause. Go through. I should erase this while I pause. We do the top part, which is going to be 20. I get minus 12 plus 15 gives me a plus 3i. And I get a minus 9i squared. Now that's going to make a plus. So that's 9, 1. That's going to give me 29 plus 3i. When I multiply this out, that's going to give me 16 minus 9i squared. That I squared makes a negative 1, so that's going to give me 16 plus 9. So I get a 25 here, and I get a 25 here. And to write it in a plus bi form, that's going to give me 29 over 25 plus 3 over 25i. Okay. And I think I needed to do, this is what I needed to do a week ago, but I ran out of time. And then there was a whole lot of stuff I needed to do, so I wanted to go back and finish this. And I do apologize. I did put 2 Khan Academy assignments. They're the exact ones I assigned a week ago. Basically, if you did them and you got them right a week ago, don't worry about it. If you didn't do them a week ago, please do the practice, because if you don't do the practice, I'd rather give you something in Khan Academy because you get the instant feedback as opposed to just something on a piece of paper. And so that's the cleanup from how do we divide complex numbers. All right, so that was the first part of today. Now, the major part of today, and it's going to continue a little bit Monday and definitely Tuesday, is we have to talk about word problems. And I talked a little bit about word problems when I first started, and then, I got a little confused. It didn't go as well as I'd like. So what I am going to do is I'm going to revisit the questions that you need to be able. What I'm going to do is I'm going to put the questions that we're going to answer, right, in a given situation, and they're not many, right? There's literally, I'm going to call it 3 with like one of them is a part A and a B, so maybe 4 questions that you have to be able to answer. And here are the 4 questions, right? But even before I give the question, even before I write a problem down, here's what we have to answer. Question 1, I'm going to talk about the initial height. Question 2, I'm going to talk about the max height. Okay? I'm actually going to say that's like 2 part A. Part B, sometimes they say what is the max height. So sometimes they say what is the max height, and sometimes they say when. Bad grammar, but I'm a math teacher, really don't care. When is the max height? Okay. And question 3 is, when does it hit the ground? When does it hit the ground? Again, awful grammar, terrible handwriting, and awful spelling, but that's not the point of this course, right? But these are your 4 questions, right? These are the 4 things you have to be able to answer given what I'm about, given whatever situation I give you. We have to talk about what's the initial height, what's the max height, when do you have the max height, and when does the thing hit the ground? And all of these are describing a parabola. And so what I'm going to do first is I'm going to draw a parabola with some made-up numbers, and then we're going to look at actual functions. Okay? There's 3 ways I can give you the problem, right? So first, let's talk about a picture so we know what's going on. And here's the picture. Picture is a parabola that looks like this. All right? Pretty much every parabola I give you is going to look like this. Okay? And there are 3 spots that are important. There's this spot, there's this spot, and there's this spot. And it turns out those 3 spots correspond to, this corresponds to question 1, this corresponds to question 2, and this corresponds to question 3. Now, for the sake of, just so we have an idea of what's going on, I'm going to create coordinates, right? Some dots up here. And so when I create some dots, let's say this is the coordinate 0, 10. Let's say this is the coordinate 3, 12. And let's say this is the coordinate 8, 0. All right. And if you think about it, when we were dealing with parabolas, I've had to make you, when I've asked you to graph the parabola, I've actually asked you to find all of these points. I've had you find the y-intercept, I've had you find the vertex a lot, right? And I've had you find the x-intercepts, right? So all of this stuff, all of this here is stuff that you've been able to find on a parabola. So let's talk about how it answers the question, all right? As far as initial height goes, right? First of all, if I ever talk about height, just the actual height, that's your y value. So in this problem, my actual height is 10. And here, I'm going to describe what's going on in this picture. At time 0, our object is at 10, right? Time is our x-axis, so at time 0, our object is at 10. Basically, you can think of it, all right, we're standing on top of a 10-foot building, right? And then I throw the ball up, or whatever the object is. After 3 seconds, so here's time 0, here's time 3, here's time 8. After 3 seconds, it has a height of 12, because your y value is your height. Your x value is your time. So for 2 part A, if I say, what's your maximum height? Well, that's like our vertex, it's 12. If I say, when do we have our max height? That's the x value. Well, it takes 3 seconds to get to the max height. And then the last question is, when does the ball hit the ground? Well, how long until it hits the ground? Well, it hits the ground at y is 0, whatever the x value is. It takes 8 seconds to hit the ground. So if you can understand this and how you can answer these questions with this picture, right, you understand what's going on. And now what I need to do is combine this with what we've done as far as graphing goes. And here's what that looks like. So first, I'm going to erase these numbers because these numbers aren't with what I currently have. So example 1. Example 1 is I'm going to give you y is equal to negative 4 times x plus 2 times x minus 6. So everybody write that down. I need to go ahead and erase this picture because I don't need it. I'm going to have to draw this one. All right. So has everybody written this down?
I'm writing it down.
Okay. So everybody write it down. All right. Now, we're going to say that this is an object. Now, the problems I've given you are in Khan Academy, and that means you have to answer 4 of them, and they're going to give you something that looks like this. This is called intercept form. And the reason it's called intercept form is or sometimes it's called factored form, is it's real easy to find out what your intercepts are. And what we're going to do, which is kind of what I made you do on your quiz, if I give you this, I want a graph. Because if I know a graph, remember how it was easy to answer these questions with a graph? It was like super easy to answer these questions with a graph. So what we're going to do is create this graph. And to create this graph isn't hard. So let's talk about how do we create the graph. Well, to create the graph, I know my intercepts. I have an x-intercept at -2 and an x-intercept at 6. Here I have one at -2, here I have one at 6. That negative means this thing's turning down. So I know it's doing this. And now I want to refresh your memory about what was important. See, how we answer these 3 questions, or 4 questions, is we need to know what's this dot, and what's this dot. Because if we know this dot, and this dot, then we can easily answer these questions. Well, one of the dots we already know, right? Because it crossed at 6. So since it crosses at 6, 0, we can already answer this question. How long does it take to hit the ground? It takes 6 seconds and then the object hits the ground. To answer some other things, like find my initial height. To find your initial height, that's your y-intercept. So for question 1, so initial height, the way I'm going to find this is the way I find my y-intercept, plug in 0 for x. So if I plug in 0 for x, that's going to give me y is equal to -4 times 2 times -6. And so my initial height is, what's that, 8 times 6, which is 48. I just found out this is the coordinate 0, 48. And so the last piece of information we need to find is our vertex, right? Because the vertex gives us this information, right? It gives us our maximum height, and it tells us when we hit our maximum height. And so to find our vertex, we have our axis of symmetry. And then you have to think about, like, the way we find our vertex. Your vertex has an x part and a y part. You have to think, how on earth do you find the x part? So our axis of symmetry, how do we find that? Well, it's exactly in the middle, isn't it? If it's in the middle, it's kind of the average. It's not kind of, it is the average. So if I average those together, let's see, that's going to be 6 minus 2 over 2. So 4 over 2. I just found out the x part is 2. And if the x part is 2, how do I find the y part? What do you do every time to find the y part?
Plug it in.
You plug it in. So that's going to give me -4. 2 plus 2 is 4. to minus 6 is negative 4. And so that's going to give me a 64. And so I just found out this is the coordinate 2, 64. So we found the 3 important points. What was my initial height? My initial height is 48. What is the maximum height? So this was 48. The maximum height was 64. How long does it take to get there? Well, according to my graph, it takes 2 seconds to get there. And when does the ball hit the ground? It hits the ground in 6 seconds. So what I'm really trying to do is connect what we know about graphing to some word problems. And really, what do you have to do to answer the word problems? These are the 4 questions I ask. You just have to know what that means as far as your picture goes. All right, so here's one question, right? Here's one way I can give you the problem. Now, let's look at another way. The other way I can give you a problem is y is equal to negative 5 x minus 4 squared plus 180. I want to answer the same questions. I want to know what's my initial height. I want to know the max height. I want to know when do we get the max height and when does it hit the ground. And how do I answer all of those? Kind of the same thing. I need to draw this picture. So when I draw this picture, the first thing I notice is this is in vertex form, meaning it's really easy to get the vertex. So when I plot it, okay, my vertex is going to be over 4 up 180. So this is the coordinate 4, 180. And I get this. Okay. So this is, right now, we already know these 2 questions. I already know my max height's 180. I know it takes 4 seconds to get to the max height. And I knew that with 0 work, right? But to answer my initial height and when does the ball hit the ground, I need to know these 2 dots. Well, to find this dot, so for question 1, I got to plug 0 in. And when I plug 0 in, let's see, that's going to give me y equals negative 5. See, that gives me 0 minus negative, so that's going to be negative 4 squared plus 180. Now that's going to give me y is equal to 16 times 5. That's negative 80 plus 180. Gives me 100. So I just found out this is the coordinate 0, 100, which means at time 0, the object's at 100. When does the ball hit the ground? Well, how do you figure that part out? Is you have to take this thing and set it equal to 0. So if I set negative 5 times x minus 4 squared plus 180, and I set that equal to 0, because I'm looking for x-intercepts, oh, that kind of looks like we were doing when we were completing the square. I'm going to divide, I'm going to do negative 5, x minus 4 squared equals negative 180. It's going to give me x minus 4 squared equals 38. Is that right? No, 36. When I square root both sides, it's going to give me x minus 4 is equal to plus or minus 6. So I get x is equal to 4 plus or minus 6. And when I solve, I find out that x is equal to 4 plus 6, which is 10, and 4 minus 6, which x is equal to negative 2. And so here's what that translates in our picture. I'm betting this is the negative 2 because it's on the left-hand side, and I'm betting this is 10 because it's on the positive side. And so if I want to know when the ball hits the ground, oh, it hits the ground at 10 because that's where it crossed. Okay. All right. So this one looks just like the other pictures. It's a parabola turning down. We have to find some things. We still have to find this. We still have to find all of these parts. And I don't know, for me, my main goal is, I always want to find the vertex first. So my vertex has an x part and it has a y part. As far as the vertex go, I know the x part is equal to negative b over 2a, so negative. Opposite of that is 20 over 2 times this. And so I end up with my x part being 2. And if I know the x part, I've got to find the y part. And to find the y part, that means I'm going to plug the 2 into this. So that's going to give me negative 5. 2 squared plus 20 times 2 plus 60. So that's 4 times 5. That gives me negative 20 plus 40 plus 60. And altogether, that gives me 80. So I have my vertex is at 2 comma 80. This is 2 and 80. So I know that my max height is 80. I know it takes 2 seconds to get there. To find my initial height. So to answer question 1, to find my initial height, that's the y-intercept, which means I need to plug 0 in for x, and that's actually pretty easy, because when I plug 0 in for x, all these go away. I get a y value of 60. And so this is the coordinate 0, 60. So it has an initial height of 60 feet, or whatever unit we have. And the last part is I have to know when this thing hits the ground. And I'm out of room, so I need to erase this. When this thing hits the ground is I want to set this equal to 0. So to answer question 3, you take whatever this is and set it equal to 0. So you get negative 5x squared plus 20x plus 60. When I set that equal to 0, now solve. How you solve a quadratic. I mean, technically, I guess you could use the quadratic formula, but I actually made this where it would work out nice. We're gonna solve by factoring. So when I'm gonna factor out a negative 5, that gives me x squared minus 4x minus 12 is equal to 0. This is gonna give me an x minus 6, x plus 2 equals 0. So it's gonna give me x is equal to 6 and negative 2. And what that looks like in my picture is this crosses at negative 2 and it crosses at 6. And so we can answer the question, when does a thing hit the ground? Oh, it hits the ground in 6 seconds. What I've tried to do in these 3 examples is given you the 3 different versions of what a quadratic quadratic function can look like. And no matter what it looks like, you can still give me these 3 points. And these 3 points are going to be the answers to the questions as far as your word problems go. So here's what I want you to do. You have